Hello, AGS1. This is the beginning of Unit 8. This is Lesson 1, or Lesson 8.1, called Going the Distance. So, as always, when we do these video lessons, feel free to pause, fast forward, rewind. Just use the video to help learn at your own pace. And the expectation here is that you have your binder open, and your binder is open to Lesson 1 in Unit 8. And you're taking notes along with me, just like we would do in class. You can pause it, work things out, check your answers, do all those good things that we do in class together. Okay, so a couple of things that we're going to do today for the learning focus. We're going to find the distance between 2 points in a coordinate plane. We're also going to work on finding the perimeter of a geometric figure in a coordinate plane. And the question I want you to think about is, how can I find the distance between 2 points if they're not on a vertical or horizontal line? Because those are a little bit easier to count. So how do we get that that diagonal distance, as we might say? Okay, so we're going to use this example here today of a performance at Crawford High School. It's their drill team. They're very popular during halftime at the school's football and basketball games. And when Crawford High School drill team choreographs the dance moves they'll use to do on the football field, they lay out their positions on a grid like the one shown. So they'll stagger themselves. That makes sense when you're in a team like that, so you can see everybody on the field. So they'll do this. But in one of their dances, they plan to make patterns holding long, wide ribbons that will span from one dancer in the middle, go ahead and highlight that one, to 6 other dancers. On the grid, their pattern looks like this. Okay, so the dotted lines that you see, that's the ribbon. There's one dancer in the middle, and then there's 1, 2, 3, 4, 5, 6. So again, folks, pause this, grab a highlighter, grab a pencil. The idea is that you're marking up your text, okay, the packet that you have in class, along with me here. Okay, so let's look at question 1. It says, the question the dancers have is how long to make the ribbons. Gabriella is standing in the center, and some dancers think that the ribbon from Gabriella to Courtney will be shorter than the one from Gabriella to Brittany. Okay, so we're going to just take a look specifically at those 2 stretches of ribbon. All right, let's first work on the stretch from Gabriella to Courtney. And that's this one right here. Go ahead and take a highlighter and just stretch that out right there. And you know what? That one's on a horizontal, so it's not that hard to count, right? So we would count 1, 2, 3, 4, 5. That's 5 units long for this one. Okay, so in question 1 here, where it says how long does each ribbon need to be, it looks like if we're on the horizontal, like from Gabriella to Courtney, it's going to be 5 units long. They haven't specifically said, like, are we talking about feet or yards or miles? Not really sure. So at the moment, we'll just call them units. Okay, and let's go ahead now and focus from Gabriella to Brittany. So let's go back here. I'm going to highlight that one in blue. From Gabriella to Brittany. Right up there. Okay, and just to kind of clear this up, I'm going to get rid of the horizontal that was there from Gabriella to Courtney. Okay, so from Gabriella to Brittany, well, that one's on a diagonal, but we can handle that. That's fine. When we have a diagonal, and that's the one that we want to find, we've worked with Pythagorean theorem. We did that on the warm-up. We did that last class. So the idea is that you get your right triangle based on that diagonal. So you want to find how long that side is, and it looks like this one is 1, 2, 3, 4. And then I want to know how wide it is as well. 1, 2, 3, 4. Sometimes we call it the base and the height. But it looks like it's a 4 by 4 triangle, and we're looking for the hypotenuse. Well, we got that. We can do that. It's right over here. So we set up Pythagorean theorem. 4 squared plus 4 squared equals c squared. That's 16 plus 16 equals c squared. That's a 32 equals c squared. So we're going to have the square root of 32 as that diagonal. That's not a nice, neat square. So I'm going to pop up my calculator here. And 32 square root. Okay, I'm getting 5.656. So that's going to round up to be about 5.7. Okay, double check that you're getting that on the calculator. So it looks like, if I were to go back to the question and make sure I'm answering that. Okay, how long does each ribbon need to be? Well, if we're on the diagonal, about 5.7 units. And if we're on the horizontal, we're looking at about, or exactly, I should say, 5 units for the horizontal. So the question, when they thought that it perhaps is shorter from Gabriella to Brittany, that actually is not true. So the diagonal in this case is just a little bit longer than the horizontal. Okay, so pause that, add to your notes, add those calculations in there. And when you are ready, let's keep going. And it looks like question, go ahead and flip the page of your binder. It says question 2 says explain how you got the length of each ribbon. You know, honestly, I think we've done that already. So let's just like say C above, because I think we've pretty well explained that above. All right, and let's go ahead. When you're ready, let's go on to questions 3. Question 3 is, about this diagram here, and then we'll keep going. All right, so question 3, let's see, let's go ahead and start, let's read this page here. When they have finished with the ribbons in this position, they're considering using them to form a new pattern like this. It's like a hexagon with kind of an X in the middle of it. Excuse me. So question 3 says, will the ribbon they use in the previous pattern be long enough to go between Brittany and Courtney in this new pattern? Okay, well, between Brittany and Courtney over here, go ahead and take your highlighter. That looks like that is right here between Brittany and Courtney. Okay, so we've got to find out exactly how long that is. But we can do that too. Any kind of diagonal. Just keep in mind that you can make your right triangle based on any kind of diagonal. So there's your vertical drop, here's your horizontal distance, and there's your right triangle. So you just want to find out essentially the difference between, right, we have a vertical difference. Think about the difference between 4 and 0, that's 4, or you can just count 4 units on the grid. And then the difference between 5 and 3, or 5 and 3, is the difference here, which is 2. All right, and then we just go ahead and use our good old friend Pythagorean theorem. We're using that a lot. So here's the setup we have here. 4 squared plus 2 squared equals c squared. So that's 16 plus 4 equals c squared. That's 20 equals c squared. C is the square root of 20. I'm using my phone calculator over here, and it keeps like, I have to keep opening it up again. So 20, the square root of 20, looks like 4.47. So we'll say that's about 4.5. Okay, so that diagonal between Brittany and Courtney is about 4.5 units long. So will the ribbon they used in the previous pattern be long enough? I'm going to go back and remember what that was. Oh yeah, sure. Because it was 5 on the horizontal, it was 5.7 on the diagonal. So now if it's 4.5, oh sure, they'll have plenty, right? They'll have plenty of ribbon. So yes, it will be long enough. Okay, great. All right, pause there if you need to. Make sure that that's good. We're going to come back to question 3 in a little bit, actually. But the next part of this is going to be coming up with what we call the distance formula. So at this point, I would just make sure, I'm just going to scroll back to the beginning. Questions 1. Did that seem okay? Questions 2, that was how we found question 1, and then question 3, hopefully that is okay too. All right, so the next part of this, kind of a new thought here. So let's go ahead, I'm going to scroll up to the top and let's read this together. It says, Gabriella notices that the calculation she's making for the length of the ribbons remind her of math class. She says to the group, hey, I wonder if there's a process we could use, like what we've been doing to find the distance between any 2 points. Highlight that, any 2 points on this grid. And she decides to think about it like this. And it's a really good idea. Okay, it's a generalization. She says, hey, you know what? If I'm going to find the length between any 2 points on a diagonal, how about I just call them, let's say, for example, in general, okay, let's call them x1 and y1, and then x2 and y2. Just a generalization. What if I just had any 2 points? And this is how we come up with formulas. Folks, we use a generalization for points. So she's like, what if I could make this into a general situation? And here's what I want you to think about. Okay, when we have any 2 points like this, go ahead and draw this in your notebook along with me. Okay, we can always, for that diagonal, drop a horizontal, right? I'm sorry, drop a vertical. And then we can also draw a horizontal like this and make a right triangle out of it. Now, if I were to make a generalization though, and I were to ask how long this side is, this vertical side, well, I've gone from y2, that's my vertical, right? The top point of y to the bottom point of y. So essentially, like, let's say, for example, this were like 8 and 5. No, that wouldn't be right. Let me at least try to make this 7, 6, 5, 4. Okay, how about 8 and 4? Okay, if I were to make that 8 and 4, well, I would subtract them, and I would say the difference between those two would be 4. So that's just a generalization. That was just an example to help you kind of think about this. But in general, it would be y2 minus y1, the top height minus the bottom height. And the same thing is going to go for this horizontal right here. If I want to know how long this stretches, let's say from 2 to 3, 4, 5, 6, 7, 8, well, then that would be 6, right? The difference between where you end up on the x and where you begin. So the generalization for the bottom part is an x, arrow this down here, is x2 minus x1. Okay, so let's go to what happens here with our generalization. So question 4 says, think back on the process you used to find the length of the ribbon and write down your steps here in terms of x1, y1, and x2, y2. Well, in general, if, back to my highlighter, y2 minus y1 and x2 minus x1, if those are our values, well, let's just go ahead and use those. I can do that. That means that x2 minus x1 squared plus y2 minus y1 squared. This is just Pythagorean theorem, folks, right? But we're just substituting in some general numbers here. Will equal, and I've called this side over here, I've called the hypotenuse d, meaning distance. It could be c. That's fine, no problem, but I think eventually you'll see this written as d a little bit more often. And that equals d squared. Well, how do we solve for d? Well, we know we just have to take the square root of the other side. So d, or the distance, equals, this is a really long formula, but it's really just the Pythagorean theorem. x2 minus x1 squared plus y2 minus y1 squared. Cool. So that means in general, folks, we can grab any 2 points and we can find the difference and the distance between them. Okay, cool. So for question 5, and I've written this out ahead of time, so you can pause and add to it as you need to. Okay, so they're asking to come up to use the distance formula. So go ahead and highlight this. This distance formula is going to come back to us quite a bit. So let's in fact label that as the distance formula. And we'll use it here to find the distance between the 2 points, negative 11.25 and 23, negative 16. So all you want to do here, folks, is just keep in mind, and we'll look at that negative 11.25. And for that point, switch colors here, I've got a lot of purple. Okay, for that point, negative 11, that's my x1, 25, that's my y1, that's just my first point. And then the second one over here, 23, negative 16, that's my second point, or my second x and my second y, or y2, or x2 and y2. Okay, toss those into the distance formula. Here is my x1. Here is my, that's my x2. Here's my x1. Here is my y2 and my y1. Okay, and you can see the work there. We're going to subtract them, square them, subtract them, square them, and we come up with 34 squared and negative 41 squared. Here they are squared over here, add them together, square root, and we have an approximate distance between the 2 points. Okay, pause that, get that down, kind of wrap your head around that one. Really, folks, it's just Pythagorean theorem with some different points. Okay, and the last question we're going to do today together, okay, we're not going to do this down here, ready for more. I don't know about you, but this feels like enough for today. So we're going to go back and find the perimeter of the hexagon in problem 3. Okay. Oh, well, actually, you know what? We've already done a lot of this work. So the perimeter of the hexagon, keep in mind that the word perimeter, I'm going to scroll back here, perimeter means that we are going to find the distance all the way around the shape. And we can do that because we found that every diagonal was 4.5. So we have 4.5, 4.5, 4.5, 4.5. So let's call it 4 of those. And then we also have 2 of the horizontals. And let's just double check on the horizontals. The horizontals are this way. And we are going from, on the horizontal, -3 to +3. So the horizontals are each going to be 6. So 6 across the top, 6 across the bottom, and then 4 of the diagonals. Okay, so 2 6s and 4 4.5s. Okay, so 2 6s and 4 4.5s. So let's see, 2 6s is 12, 4 4.5s. I need my calculator for that tonight. Okay, 4 times 4.5, that's 18. So 12 plus 18, that is going to give us 30. And again, we're not quite sure the units, so we'll just call them units just to be safe. So the perimeter of that hexagon would be 30 units. Oh boy, I'm getting low battery notifications. That's my sign. All right, folks, that is what we're going to be working on today. Make sure that you have updated your notes. Your homework should be written on the board in the classroom. It's also on Canvas, but you're going to be practicing with the distance formula, and you're going to be practicing using Pythagorean theorem on the coordinate grid. Okay, I hope to be back to be working with you soon. It's been fun, and go back to this anytime you need to. All right.